All right, let's dive right in. Today, we're going to talk about something called network architecture. Okay, so have you ever stopped to think about how your group chat actually works? Or, when you're playing an online game, how do all those computers, phones, and consoles talk to each other so fast? Well, I'll tell you, it's not magic. It's all because of a very specific design. And that's exactly what network architecture is. It's the design. The best way to picture it? Think of a blueprint for a house. I mean, it can't just throw up walls and hope for the best, right? You need a plan. Network architecture is that plan, but for computers. It's the master blueprint that lays out exactly how they're all going to talk to each other. So if it's a blueprint, what's actually in it? What are the pieces? Well, it really just boils down to two main things. First up, you've got something called topology. Now, don't let the fancy words scare you. It's just the layout of the network. Seriously, that's it. Think of it like a seating chart for all the computers. It's how they're all arranged and connected to each other. Okay, so the second piece of the puzzle is the data transmission mode. This just decides how data actually moves around. Is it a one-way street where information only flows in one direction? Or is it more of a two-way conversation where data can go back and forth? It basically sets the rules of the road for all the information zipping around the network. And that's it. It's actually a super simple formula when you think about it. You take the layout, which is the topology, and you add how the data moves, the transmission mode, and boom, that gives you the network architecture. Seriously, if you remember anything, remember this little equation. It's the key to the whole topic. All right, now that we've got the building blocks down, let's talk about the two main designs you're going to see out there in the wild. Pretty much every network you use every day is built on one of these two models. So take a look at these two pictures. They tell the whole story, really. On the left, you've got a network that has a clear boss in the middle. But on the right, it's a totally different vibe. Everybody's equal. Let's jump in and see what that actually means. First up is what I like to call the teacher-student network. And trust me, this analogy is going to make it click. This right here is the famous client-server model. Look at how it's set up. You have one big central computer, that's the server. That's our teacher or the boss. All the other computers, the clients, are the students. They all connect to the teacher to ask for things. Okay, the key word here, and this is a big one for exams, is centralized. Everything, and I mean everything, goes through that one main server. It's the hub. When you go to a website, your computer is the client asking for information. The website server is the provider that sends it back. This organized setup is why it's used for, well, almost everything. School networks, your favorite websites, they all work this way. Now let's flip the script and look at the second model. Instead of a classroom with a teacher, let's call this one the study group network. This is the peer-to-peer model, or P2P for short. And the first thing you probably notice is there's no central server. The teacher has left the room. It's just a study group. Everyone is a peer, and they're all just sharing notes and files directly with each other. No middleman. So if the other model was centralized, this one is the exact opposite. It's decentralized. That's the big exam term for P2P. No boss, everyone's on the same level. Any computer can be a client asking for something, and it can be a server providing something. It's all about direct sharing. You see this a lot in file sharing apps or even some online games where you connect straight to other players. Okay, that's a lot to take in, so let's do a quick final exam review. We're going to lock in these ideas so you don't forget them. Just look at this comparison. It really makes it crystal clear, doesn't it? Client-server, centralized. It's got a boss. Peer-to-peer, decentralized. Everyone is equal. If you walk away with one thing today, it should be understanding the difference between those two words. That's the money shot right there. And here's your cheat sheet, the whole topic on one slide. Remember our formula, layout plus data flow equals architecture. And the two main types, centralized client-server and decentralized peer-to-peer. That's the foundation of everything we've talked about. Okay, let's hammer this home one last time. Point 1. Architecture is just the layout plus how data moves. Point 2, client-server is centralized, like a teacher in a classroom. Point 3, peer-to-peer is decentralized, like a study group. And finally, you have to know the difference. I guarantee you this is a super common exam question. So, I'm going to leave you with a practice exam question. Think about it. Using our teacher and study group analogies, can you explain two big differences between client-server and P2P networks? Pause and really think about it. If you can nail that answer, you've totally got this. Thanks for tuning in.
All right, so picture this. You're in the library with your friends trying to knock out a big group project. You've all got your laptops, you need to share notes, and there's only one printer for the whole group. How do you connect everything together fast? Without some complicated IT setup? Well, that's exactly what we're diving into today.
So that brings up a really interesting question, doesn't it? How do you build a network with no boss? A network where no single computer is calling all the shots, and it's a real team effort. Well, the answer is something called peer-to-peer networking. And trust me, it's way simpler than it sounds.
So the solution to our library problem? It's called peer-to-peer networking, or P2P for short. Just think of it like your project group. Everybody's an equal, right? There's no team captain, no one person in charge, just a team of equals getting the work done together.
Okay, now this is super important, especially for your exams, so listen up. Here's the official definition. A peer-to-peer network is where all the computers, and we call these nodes, have totally equal relationships and responsibilities. The key thing to remember is this: there is no central server calling the shots. None. Zilch. And this image here, it shows that idea perfectly. Node A is totally equal to Node B. There's no top-down structure, no boss and employee relationship. Everyone is a peer. They're on the same level. And hey, here's another exam tip. This kind of setup is also called a work group. You'll probably see that term pop up.
All right, so P2P networks have some really awesome features, and I like to think of them as superpowers. The first, and maybe the most important one, is the power to share pretty much anything you want directly from one computer to another. I mean, look at this. It's like a complete circle of sharing. It doesn't matter if it's data, like your project files, or hardware, like that one printer, or even software. Everything can be shared with everyone in the group. It's all about making collaboration a breeze. So what does that actually look like in the real world? Well, it means you can zap your project files over to your friends instantly. Everyone can connect to that one printer, no problem. You could even share a single internet connection with the whole group. See? It just makes teamwork so much easier. Okay, moving on to superpower number 2. You're your own boss. The fancy term is decentralized control, but all it really means is there's no need for some special IT person or a system administrator to run the show.
And this is a really big deal. Since there's no central server, you don't need a central manager. You are in complete control of your own computer. You decide which files to share, which printer to make available, and who gets to access it all.
But you know what they say, with great freedom comes great responsibility. The big takeaway here is that while you have all this power, you're also in charge of your own stuff. That means you're the one who manages your computer security and who you give sharing permissions to. All right, let's talk about the third and final superpower, fault tolerance. Now that sounds a bit technical, I know, but all it really means is that the network is super tough to break. It's pretty much unstoppable. So check out this diagram. Let's say you have these 4 computers all connected. Now, what happens if one of them just crashes? Or someone unplugs it by accident? In a peer-to-peer network, it's not a big deal, seriously. The other computers just carry on talking to each other like nothing happened. One computer failing doesn't wreck the whole network, and that's a massive advantage because your team can keep on working even if someone's laptop decides to take a nap. Okay, so we've established that P2P networks are pretty powerful, but where do you actually use them? Because, let's be honest, they're not the perfect solution for every single situation. They really have a specific place where they shine. P2P is absolutely perfect for small-scale stuff. We're talking a small office, a classroom, your study group in the library, or even just connecting a few devices in your own house. And why is that? It's simple. They're super easy to set up, and you don't need any expensive, complicated server equipment. All right, time for a super quick recap. Think of this next part as your grade A+ cheat sheet. It's perfect for that last-minute revision right before an exam. Let's nail this down. Okay, let's go. First, what is it? It's a network of equal nodes, and remember that other name for it, a work group. OS? Don't worry, all the modern ones have you covered. Windows, Mac OS, Linux, you name it. Where is it best? Think small and local. Offices, rooms, places like that. And finally, the features. This is the big one. Just remember our 3 superpowers. You can share everything, you don't need an admin, and it's tough to break, since one failure won't bring the whole thing crashing down. So there you have it. That's peer-to-peer networking in a nutshell. It's simple, it's powerful, and it's super useful when you use it in the right place. So I'll leave you with this final thought. Now that you know how to build a network of equals, where could you use one in your own life? Maybe for a gaming session with your friends? Or just to easily share files between computers at home? The possibilities are pretty much endless.
Have you ever streamed a movie, played an online game, or even just logged into a computer in your school's lab? Well, believe it or not, you're using something called the client-server network. And in the next few minutes, we're going to break down exactly how that works so you can see the magic that's happening right behind your screen. So let's jump right in. I mean, really think about it for a second. How can, say, 30 different computers all open the exact same project file or use the same printer without everything just crashing? It seems like it should be chaos, right? Well, the answer is a really clever system called the client-server model. It's kind of like an invisible traffic cop that keeps everything organized and running super smoothly. Let's see how it pulls it off. So, here's our game plan for today. We'll start with the basic definition, then we'll meet the key players. After that, we'll figure out who's in charge, discover the network's 3 amazing superpowers, and then finish up with a cheat sheet to help you ace your exams. Sound good? Okay, first things first. What exactly are we talking about here? This is a really core concept, so let's get this definition locked in right away. All right, this is the official definition you'll absolutely want to remember for your exams. A client-server network is basically a team effort. You've got these powerful computers called servers, and their whole job is to provide services. And then you have the clients. That's your laptop, your phone, the computer in the lab, and they use those services. So one provides, and the other uses. Simple as that. To really get this, let's properly meet the 2 main players on this team, the client and the server. You know, the best way to think about this is to imagine a restaurant. It's the perfect analogy. The client is you, the customer. You're the one asking for or accessing a meal. The server, on the other hand, is the kitchen. It's the powerful provider that prepares and delivers exactly what you asked for. In the computer world, the client asks for a web page or a file, and the server provides it. See? Super simple. Okay, so now that we know the players, let's talk about who's in charge. Because in this model, one player is very, very clearly the boss. And yep, you guessed it, the server is the boss. It's the central controller for the entire network. I mean, look at that little crown. It's there for a reason. This isn't just any computer. It's a specialized machine that manages everything. We're talking files, printers, internet access, the whole shebang. And it controls how all the clients get to use these resources. Of course, a boss needs special tools to do its job, right? A server doesn't just run the same Windows or Mac OS you have at home. No way. It uses a powerful, specialized operating system. Things like Windows Server or different versions of Linux. These are built from the ground up to handle maybe hundreds of requests at once, manage security, and just run 24/7 without ever crashing. That's what gives the server all its power. So now that we know who's in charge, let's look at the major advantages of having this kind of system. We're going to call them the network's 3 superpowers. And listen up, because these are the key benefits you absolutely need to know. This is a very common exam question. So why do schools, big offices, and pretty much every website on the internet use this model? What makes it so effective? Well, the answer really boils down to 3 key superpowers: safety, efficiency, and control. Superpower number 1 is safety. Because all the important files are stored on that one central server, it is incredibly easy to back everything up. Just imagine trying to save the data from 30 different computers one by one. It would be a nightmare. Instead, you just back up the one server. It's like having one giant super secure vault for everybody's work. Next up, superpower number 2, efficiency. See, the server is a dedicated machine, and that's a key word. It means it's not trying to run video games or web browsers at the same time. Its only job is to serve the clients. And because it's so focused and so powerful, it makes sharing things like files and printers super, super fast and reliable for everyone. And the final superpower is control. This one is all about security. Because everything has to go through that central server, it's so much easier to manage who gets to see what. Access can be controlled from one single place. Now here's a key phrase to remember for your exam. You might want to write this down: centrally administered. That just means the boss is in full command. All right, we've covered a lot of ground. Now let's pull it all together in a handy little exam cheat sheet to make sure all this stuff really sticks. And here it is. This is your golden ticket for revision. Let's do a quick recap. We've got the model, powerful servers helping out the clients. We've got the boss, the server, which is our central controller. We've got the software, those specialized operating systems. And most importantly, the 3 key benefits: safety from centralized backups, speed from having dedicated servers, and security from that central administration. And to help you even more, here are some typical exam questions and the exact keywords that will get you top marks. So if you're asked for a definition, make sure you use server provider and client accessor. If you're asked for the advantages, you're going to want to use those key phrases for safety, speed, and security. This table right here is your guide to a fantastic answer. And hey, if you need a super simple way to remember all of this, I've got a great little memory trick for you. For the model, just think the client asks and the server provides. Simple, right? And for the benefits, just remember the 3 S's: safety, speed, and security. It really is that easy. So remember, this isn't just some random topic for your computer class. It's the backbone of the entire modern internet and pretty much every digital service you use. From your school network to the apps on your phone, you are interacting with clients and servers all day long. So now that you know the secret, can you spot them? Okay, so think about this. Every single day, you grab your phone, you tap Join Wi-Fi, and bam, you're online. But have you ever actually wondered what's happening in that split second? What's the secret language your phone is speaking to the internet to make it all work? Well, that's exactly what we're going to break down today. We're talking about network protocols. You can think of them as the internet's secret rules. And trust me, understanding them isn't just a cool party trick. It's super important for your exams and for, understanding the world you live in. So let's start with the big picture. Before we get into all those acronyms you need to memorize, we first have to get a handle on what a protocol even is. What are these secret rules anyway? Honestly, the easiest way to think about it is like grammar for computers, right? When we talk, we follow rules of grammar so that other people can actually understand what we're saying. Well, protocols are the exact same idea, but for computers. They're the set of rules they have to follow to send and receive information. Without them, the internet would just be a total mess. Now, for everybody taking notes, and you probably should be, this is the official exam-ready definition. A protocol is a set of rules followed for interconnection and communication between computers in a network. Bottom line, no rules, no communication. It's really that simple. And just like any good system, there's a main rulebook. For the internet, the big one is called TCP/IP. That stands for Transmission Control Protocol and Internet Protocol. So think of the IP part as the one that figures out the correct address to send your data to, kind of like a postal service. And TCP is the part that makes sure all that data actually gets there in the right order with no mistakes. They're the power couple that runs the internet. All right, let's put this into practice. Imagine it's a regular school day. The first thing you do when you walk into the library is connect to the Wi-Fi. So how does that even happen? What's that very first step? This is where a protocol called DHCP steps in. DHCP, or Dynamic Host Configuration Protocol, is kind of like a friendly host at a party who finds you a seat. The second you try to connect, DHCP automatically gives your phone its own unique address, an IP address. This address is basically your phone's name tag for the network, letting it send and receive stuff. It's the reason connecting to Wi-Fi is so ridiculously easy. Okay, so you're connected. Now the fun starts. Whether you're doing research for a project, emailing your teacher, or sharing files with a friend, you're about to see that each of these different actions uses its own special protocol. So you open up a web browser and you type in google.com. Here's the thing though, computers don't really understand names like that. They speak in numbers, those IP addresses we just talked about. So how in the world does your computer find the right number for google.com? It uses something called DNS, which stands for Domain Name System. And honestly, the best analogy for this is to just call it the internet's phone book. It's that simple. You look up a name you can remember, like google.com, and DNS finds the right phone number, the IP address, that your computer needs to make the call. So once your browser has that address, it uses another protocol, HTTP, to do all the heavy lifting. HTTP stands for Hypertext Transfer Protocol, and its job is to go out and grab all the pieces of the website, all the text, the pictures, everything, and bring them back to display on your screen. But wait a second. Let's say you're not just browsing. What if you're actually shopping online and you have to type in your credit card number? Can you trust that HTTP is keeping that information safe? No way. And that is where HTTPS comes to the rescue. See that S at the end? That S is everything. It stands for secure. HTTPS creates a protected, encrypted link between you and the website, basically building a secret tunnel for your data so hackers can't see it. You should always look for that little padlock in your browser's address bar. So for your exams, this is a really critical point to remember. Using HTTP is like sending a postcard. Anybody who gets their hands on it can read what it says. But using HTTPS, that's like sending your information in a locked box that only the right person can open. All right, your research is done, and now it's time to email that homework assignment to your teacher. And you guessed it, email has its very own set of protocols to make sure that happens. Now listen up, because this is a spot where a lot of students get mixed up. To send an email, your computer uses SMTP, the Simple Mail Transfer Protocol. Think of SMTP as the mailbox you drop your letter into. But to receive and download your emails, you use different protocols like POP3 or IMAP. They're like the mail carrier who brings the mail to your house. They're separate things because sending and receiving are two totally different jobs. Okay, one last thing to do today. You've got this huge video file for a project, and it's way too big to attach to an email. So what do? Well, you use FTP, the File Transfer Protocol. It's designed for one thing and one thing only, moving big files from one computer to another nice and easy. Whew! I know, that was a whole lot of acronyms, but don't worry. To help you get all of this straight for your exams, we've boiled it all down into one simple cheat sheet. Let's just quickly run through this together. We started with TCP/IP, the big boss, the main rulebook for the internet. Then there's DHCP, which gives your device an IP address. We've got DNS, the internet's phone book. HTTP is for browsing websites, and the super important HTTPS is for browsing them securely. And then you've got your two specialized protocols, SMTP for sending email and FTP for transferring big files. Seriously, pause here if you need to. This table is going to be your best friend. Okay, let's make sure all of this actually sticks in your brain. We're going to do a super fast recap, and then I'll give you a really simple memory trick for the ones that are easiest to mix up. So what do you absolutely have to remember? 1. Protocols are just rules for communication. 2. TCP/IP is the main rulebook for the internet. 3. Different tasks need different protocols. And 4. When in doubt, look for that S in HTTPS for security. And here it is, a super easy trick to remember the tricky ones. For SMTP, just remember the S stands for sending mail. For POP, think of it as pulling your mail down from the server. And FTP is the easiest of all. The F is right there for file transfer. See? Simple. So as we wrap this up, just think about this. Protocols are like the unsung heroes of the internet. They're working silently in the background 24/7, connecting our entire digital world. Pretty cool, right? You've just learned the basic grammar of the internet, which is a massive first step. So the only question left is, now that you know these rules, what other secret languages that power our world are you going to learn next?